discussed.
Sir, the question that you have given, sir, we have to solve. Sir, you told, sir.
Huh?
Sir, the question that you have given, we have to solve, or you
No,
will.
no, I'm discussing. Okay.
Okay, sir.
So all of you know the row major and column major order. Okay. So first we need to create some formula. Here we can write address of an element. Okay, address of an element of any array. Suppose say a I, okay, ai j is calculated as given is calculated as given in row major system. So aij, one array is given. Okay, we need to find out the address of any 2D array of a. ith a is the array name, and ith location, ith row and jth column element address we need to find out. Okay, so one array already is there, a array. Okay, and we will need to find out the address of ith row jth column element. Okay, if we store all the data of any array if row major order, and if we store all the data in our array in column major order, we need to find out the address of that particular element. Okay, so row major system. Okay, what is the address of row major system? How to calculate the address? So write down address of a I j. Okay, address of a I j equals to b plus w into n into I minus lr plus j minus lc. Okay, and column major order, if we write in column major order, okay, column major system, what is how to calculate the address? Okay, so address of a I j means we want to find the address of a array, ith row and jth column element. Okay, if we store this element in column major order, then what is the address? B plus W into I minus LR plus M into, okay, J minus LC. Okay. Write down. Complete?
Yes, sir.
Yes, sir.
Okay. Now, what is B? Okay. What is B?
Base address.
B is nothing but the called base address. Okay, is nothing but base address, means starting address. We know we need to find out the ith row and jth column element. What is W? W is nothing but storage size, okay, of one element. Storage size of one element stored in the array. Okay, storage size of one element stored in the array. Okay, it is in byte, which is in byte. Okay, what is LR? LR is lower limit of row. Lower limit of row, or we can say start row index of matrix. Start row index of matrix. Start row index of matrix. Okay, if not given, assume 0. Okay, if not given, assume 0. If not given, assume 0. Okay, what is LC? LC is lower limit of column. Lower limit of column. Okay, or start column index of matrix, or if not given, assume 0. Okay, if not given, assume 0. Okay, what is capital M? Number of rows, total number of rows. Okay, number of row of the given matrix. Number of row of the given matrix. And what is N? Number of column of the given matrix. Number of column. Number of column of the given matrix. So B is the base address, W is the storage size of one element stored in the array in byte, LR is lower limit of the row, LC is the lower limit of the column, N is number of row, N is number of column. Okay. Similarly, UR is upper limit of the row and UC upper limit of the column. Upper limit of the column. Okay. So usually number of rows and column of a given matrix is like this: A 20 30. Okay. Find out the address of A2030, or any array is like A2030. Okay. Array A is A2030, and find out the address of A suppose 10 20. Okay. Find out the address of A10 20. So this total, my main array is A2030. That means 20 number of rows and 30 number of columns. Okay. 20 number of rows and 30 number of columns. So we can write any array in different way, like AILR dot UR comma LC comma dot UC. Okay, we can write in this way. So this is my array, total 20 rows, 30 columns, or we can write, now forget about these things now. Okay. This is my main array, 20 rows, 30 columns, or we can write in this way. That means a array indexed, suppose that means 0th row, 1 row up to, what is the last row number? Row index 19. Here 0th column, 1 column, what is the last column number? 29. Yes or no?
Yes.
Hello? Okay.
Yes, sir.
So total
Yes.
19 and 20 row. So
Yes, sir.
array index, row index starts from, this is row index. Row index starts from 0. Last index is 19. Here column, this is my column. The column index starts from 0. Last index is 29. So how can we write low LR? What is LR? Lower limit of row. What is the lower limit of row means? For starting index of the row. Starting index of the row is here 0, comma. What is the last index of the row? 19. This is UR. R stands for row. LR means lower index of the row. Lower index of the row is 0. So that's why it is 0. What is UR? UR is the upper index of the row. What is the upper index of the row? 19. LC. L stands for lower. C stands for column. So lower index of the column. What is the lower index of the column? 0. What is the upper index of the column? UC. U for upper, C for column. So upper index of the column. What is the upper index of the column? 29. Okay. Any question? Are you getting my point?
Yes, sir.
Okay. So 20 rows, 30 columns, my array. So we can write this array in this way also. This is also 0, row starts from 0. So how can we find out the number of rows? M is number of rows. This is nothing but number of rows. Okay. You know M. How to calculate M? Upper index of the row minus lower index of the row plus 1. So 19 minus 0. What is 19 minus 0? 19 plus 1, 20. You can see 20. And N is UC minus LC plus 1. N is total number of column. So 29 minus 0. 29 plus 1, 30. You can see total number of column is 30. I want to listen from everyone. Any doubt? Any question?
No, sir.
No, sir.
No,
Okay.
sir. Got it, sir.
Okay, got it? So, in your question, suppose one 2D array is given like this, A 2030, or you can say the array given like this: a 0 to this, then 0 to 29, or 1 to something. Suppose this question here, in this question you can see this is my x array. Okay, so starting index -5. What is -15? This is
LR.
lower index
LR.
of the row. 10. What is 10?
Upper index of the row.
Upper
You
limit.
know how to remember? You know any array, first part is row, then second part is column. Okay. Suppose if we declare any 2D array like 2, 3, that means this one represent row and this one represent number of column. Similarly, here first row. So LR means lower limit, lower index of the row -15, upper index of the row 10. Similarly, LC, lower index of the column, this is UC, upper index of the column. Okay, you know this. Now find out the, so we need to, according to the formula here, you need to find out the address of, it requires 1 byte of storage. So what is the W value? 1 byte of storage. To store one element, we required 1 byte. What is the W value?
1.
1. To store one element, how many byte is required? Suppose it is character array, it's required 1 byte. Integer array, either 2 byte or 4 byte. Floating type array, 8 byte. Okay. Similarly, my beginning location is 1500. Beginning location is 1500. So according to this formula, which parameter value is 1500? Which
B.
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 Right. B. B is the base address. Base address means starting index, starting address of the array. That means this is nothing but the address of 0, 0 location. Okay, 0th row, 0th column, 0th row, 0th column element. So 0th row, 0th column element, or beginning location is 1500 means base address is 1500. Now determine the location of x 1520. Okay, 15th row and 20th column element address we need to find out using row measure order and column measure order. Find out the address, so that means this array starts from -15. Okay, -15. -15 to 10, and here column starts from 15 to last index is 40. And suppose there are element, this is the element. Okay, suppose this is this is one of the element. No, 15 to 20th column. Okay, so -15, yes, -15 to 10, -15 to 10, and 15 to 40. Okay, so -15, 1, 2, 2, 3, 4. Okay, and here 15 to 20. Okay, so determine the location of x 15, 20. Okay, so can you please tell me what is the total number of rows?
26.
26.
26. Okay, so m equals to ur minus lr plus 1. what is UR value? 10 minus LR value minus 15, okay, plus 1. So 10 plus 15, 25 plus 1, 26. So number of rows is 26. What's the number of columns? Similarly, you can find the n value. N value is
26.
UC minus LC, okay, plus 1. What is UC value? 40. What is LC value? 15 plus 1. So 14 minus 15, 25 plus 1, 26. So it's a square matrix. Okay, 26 rows and 26 columns. So we know the value of B, we know the value of W, we know the value of N, we know the value of M. Okay, what is I value? I value is 15, J value is 20, because this is I and this is J. Okay, we need to find out the address of X, 15, 20. So I value is 15, J value is 20. Okay, I value 15, J value 20. So we know I value, also J value, I value, J value we know, LR value we know, LC value we know, LC value we know. So we can calculate the address using row measure order and column measure order. So find out the address.
So is the answer is 2285.
Which order?
The
Row measure.
Okay.
The column measure order is 1660.
Okay. So you know M value, N value, just put within the formula.
So column measure is 1650.
Column measure 1650, no, 1660.
Yes, sir.
Yes, sir. 165.
Suppose just B value, what is the B value? B value is
1500.
1500.
Yes,
Okay,
sir.
so 1500 plus 1 into N 26, I value 15 minus LR means minus 15. Okay, so here minus 15, so minus minus a plus J value is 20 minus LC value is 10. Okay, LC value is 10, so you can calculate. Have you completed, all of you? Any question?
No, sir.
Okay. Suppose one array is given ARR 1 to 10, okay, and 1 to 15. 1 to 10 and 1 to 15. With a base value is equals to 100, and the size of each element 1 byte. Okay, Size of each element 1 byte. Find the address of ARR8 6 in column measure order. Only in column measure order. Find out the address of A86. One array is given, okay. Base value is 100, and to store one element we required 1 byte of memory. Find out the address of ARR86.
One 77.
182.
No. In column measure order?
177.
No. What is the B value?
So it's 157.
Base address is 100.
100.
What is the W value?
So 1.
1. To store one element we required 1 byte. What is the I value?
I8.
What is the J value?
6.
157.
So
LR?
1.
1.
LR value?
1.
This is my LR and this is my UR. This is my LC. This is my UC. Okay. So LR value 1. What is UR value?
10.
10. UR value 10. LC value?
1.
LC value 1. UC value?
15.
15. Okay. We want to find out in row measure order. A column measure order. So column measure order, we know B value, we know I, J value we know, W value we know, I value we know, LR, J, LC value we know. But we don't know M. Okay, means total number of rows. So how to calculate total number of rows? You know,
So you are minus LR
plus
1.
UR minus
Minus
LR
LR.
plus 1. Okay, so UR minus LR plus 1. UR value is 10
10.
minus LR value 1 plus 1
So it's
equal to
10.
10. Now put the value.
157.
157.
157. Yes. So in column measure order, the value is 157. So this type of questions may come to your mid-sem exam or also end-sem exam. Okay. Now, discuss another topic which is called traversing. What is traversing? Anyone? You know? What is traverse? Traversing means visit all element. Okay, visit all element of the array. Of the array or any other data structure, visit all element, it is called traversing. Now, we want to write down one algorithm to traverse an array and print all the data. Suppose we have one array. Okay, we have one array 0, 1, 2, 3, 4. Here array name is suppose A, Okay, here we assign value, suppose 5, 2, 8, 3, 7. Our aim is to traverse from starting index to the last index or last index to the starting index. Okay, if you want to print an array in reverse order, so we need to traverse from back and forth, means from last to first. And if you want to print the data of any array from first to last, so we need to traverse from 0 to 4. If you want to print the data of any array reverse order, we need to traverse from 4 to 0. Okay, or when traverse is required, suppose someone asks you how many even number is present into your array, or how many odd number present into an array, or add plus 3 with all the numbers. Okay, so for any cases, for any operation, we need to traverse an array. Okay, suppose you want to find the shortest element of any array, find the largest element of any array, so that means that time we need to traverse an array. Okay, so these are the applications where we can use traversing. Okay, if you want to sort any array, if you want to find the smallest element, largest element, if you want to reverse, want to exchange the value between two location, so for any kind of operation we need to traverse. Okay, so now today I'm going to discuss how to write down any algorithm. Okay, first I write an algorithm. Don't need to study any book, just check. Okay, algorithm. Okay, now give the name of any algorithm according to your. Suppose we can write array underscore traversing, traverse array, array traverse. Okay, or we can write only traversing, any name as your choice. Okay, traversing. Okay, now we need to pass two parameters. What are the parameters we need to pass? If we want to traverse an array, what are the requirement? If you want to traverse any array, what are the requirement?
Sir, the given array and the size of the array.
Okay, so given array is required because which array you want to traverse? The given array, and we know the starting index. Here we assume that the starting index of any array, if we store any array into our primary memory RAM, we cannot change the index. Its index starts from 0 and last index is total size minus 1, right? So in pen and paper, we can say that array starts from minus 15, minus 3, minus 2. In pen and paper, we can do, but if we want to store the data into our primary memory RAM, array index starts from 0. So need not to pass the starting index. Okay. Or if you want, you can pass the starting index, but need not. But starting index not required. Now, what we need to know, the array name, which array we want to traverse, and we need to know the total number of element, which is represented by n. Okay, so these two things we require. We know that one is name of the array, which array we want to traverse, and the total number of element of the array. Now,
Sir,
yes,
sir, can we use size of instead of passing the array?
can we use?
Sir, instead of passing the size of the array, can we use size of function?
Size of?
It's like the function size of a.
No, I am not talking about any programming language. You can find the size of a, that means it returns 5. Okay, I am not talking. I am talking about the algorithm. You can implement in any language. Okay, you can implement in any language. I am just showing you what is the logic, how to find or how to write any algorithm. You can give this algorithm to any C programmer or any C++ programmer or Java programmer. They can design in his own way. They know which function is required and what are the functions, how that function used. But I am showing you how to write an algorithm. Okay, so algorithm traversing A and N. Now you need to write when you write any algorithm, because your friend don't know. If you pass this algorithm to your friend don't know what is a and what is n. Okay, so that's why you need to write within mm, command line. Okay, a is the base address. Actually, we are not passing, it is a very wrong concept. We are not passing the name of the array. When you write any program, we are passing actually the base address of the array, right? Base address is the base address of the array. Okay, and what is n? N is the number of n. N is the number of element. N is the number of element of the array. N is the number of element of the array. Okay, complete. Now you can use begin end. You can write begin or at the end, or you can use open curly braces, end curly braces. But I will prefer open curly braces and end curly braces. Okay, I am going to write any algorithm in terms of function. Okay, so if you give this algorithm to any person, any C programmer or C++ programmer, they can design the function of traversing. Okay, now if you want to traverse, from where we traverse, according to this diagram, from where we traverse, suppose I represent the index of the array. Okay, so for traversing, we need if else block or loop. To traverse an array, suppose we visit first 0th location, then we visit 1 location, then we visit 2, then we visit 3rd location, then we visit 4th location. Okay, so to traverse each position, we need loop. So for, we can write for I equals to 1 or I equals to 0, 2, I equals to 0, 2. Okay, so it starts from 0 and where we end?
N.
Not n. I represent the index. What is the index of the last element?
n minus 1.
4. N minus 1, right? Total number of element 1, 2, 3, 4, 5. So n value is 5. But what is the last index? 4. So n minus 1. Okay, so for you can write in you can instead of for you can write while loop or any other loop also, doesn't matter. Okay, correct. Do so for I equals to 0 to n minus 1, means first 0, then 1, then 2, up to n minus 1, where n is the number of element of the array, and we traverse each location and print ai. Print ai. Okay, print ai means ith element we need to print. So first we I value equals to 0. What is a0? A0 is 5. Here we print 5. What is then I increment next value of I 1. What is a1? 2. Okay, so if you give this algorithm to any C++ programmer, here he or she can write printf on if any sorry is any C programmer, here he can see write printf, any student can write printf %d comma comma ai. Or if you give this algorithm to any C++ programmer, he or she can write c out AI, right? Or any Java programmer, they can write system.out.println. Okay. So algorithm is not language dependent. Okay. So if you can write any algorithm easily, that you need to know, first you need to write the algorithm, then you have to write the name of the algorithm, then the what are the parameter we need to pass, because if you want to traverse any array, we require the array. So first we need array, and what another things we require, we need to know the total number of element 10. Now, so but your programmer don't understand that what is a and what is n. So that's why within command line you need to write a is the base address of the array and n is the number of element of the array. Okay, so programmer can understand. Oh, a is the base address and n is the number of element. Now for I equals to 0, so we you know that any array starts from 0. So I represent the index I equals to 0 to n minus 1. Okay, because total number of element n, so you need to write last index is n minus 1. Do print ai. Any doubt? Any question?
So,
Yes.
sir, since you have written algorithm traversing, so all the means all the operations of the array will come under this one. No?
All the operations means you can find, we can perform any operation without traversing is not possible. Suppose we want to reverse of any array. That means what? For I equals to n minus 1 to 0. Suppose in your exam, suppose there is write an algorithm to reverse one array. Okay, write an algorithm to reverse an array. So same algorithm, you can write, suppose algorithm you had, we instead of traversing you can write reverse underscore array or reversing or whatever. You need to pass two value, one is a, means base address of the array, and total number of element. Now for I equals to 0, for I equals to 0, here we need to write I equals to traverse in this way. Reverse of an array means we need to traverse from last index to the first index. So I equals to n minus 1 to 0. Am I right or wrong?
Yes, sir.
Okay,
Yes,
I
sir.
equals to n minus 1 to 0. Print ai.
Okay, sir, got it, sir.
Okay.
Sir, and if we have to interchange the means two digits of the array, then
Okay. So suppose so then another if you want to insert a new item, okay, I will show. Okay, algorithm how to insert an item, how to delete an item. I will discuss in the next class. Okay.
okay, sir, okay, sir.
Means suppose one array is given, so array size is large. Okay, array size is large. Suppose we want to insert one element in this position. How to insert one element in this position? You can't delete any item. Okay, if you want to insert one element at second position, suppose you want to insert 9. If you want to insert 9 in this position, how to insert? If we shift this element 1, then we shift this element, then this place is vacant. Okay, this element here, then we shift this element here. Now this place is vacant. Now you can insert 9 here. We shift 7. Suppose कोई बेंच में बैठा है, नया कोई आया है, अरे थोड़ा घसक तो. Similarly, 7 we shift in this location. Suppose this location is 5. So now this place is vacant. We shift 3 in this location. Now this place is vacant. Now we shift 8 in this location. Now this place is vacant. Now we can insert 9 in this location. So what are the values we need to pass here? The array name, okay, total number of elements, okay, array name, because if we know the n value, so n value total number of elements suppose 5. So what is the last index? We know n minus 1. So n minus 1 is this last index. We need to shift in the next index, okay, and but in which position we want to insert? 2. So we need to know the position and what element we want to insert? 9. So 4 things is required: array name, total number of element, the position and item. Position where is second position and item is 9. Are you getting my point? Yes or no? I want to listen from
Sir, the
everyone.
point is clear, but how we'll write it is not clear, sir.
Okay, we will discuss in next class. Okay, how to write, how to insert, how to delete. If I give some example like how algorithm of traversing, algorithm to insert an element into an array, algorithm to delete an element into an array, algorithm to update any element from an array, okay, then you can write any. I am discussing here only one thing. Don't try to mug up from any book. You can write your own algorithm. You are an, what all of you are an engineer. Okay, don't try to just write algorithm, then name of the algorithm, then what are the parameters you need to pass. Okay, then you can write your own logic. Okay. So suppose in your question, suppose different type of questions may come. Suppose write an algorithm to sort the array element, or write an algorithm to find the mm, even number of even number. Okay, total number of even number. Write an algorithm to find the total number of even number and odd number from an array. So you can write easily. Okay. So in the next class we will discuss.
Okay, sir. Okay, sir.
Any student, any question? Any doubt?
No, sir.
Roll number 5101. Omlan Bhattacharya. 119.
Present, sir.
148. 148 Sanjeev Chaube. 165
Present, sir.
Sanjeev Chaube present.
Yes, sir. Present. Sanjeev Chair present.
Okay. If someone responds in chat, please tell me. Okay. Okay. 165 present. 168. 168 Tushar Sahu. 205.
Sir, Tushar sir present.
205 Harsh Kumar. 207
Present, sir.
213
Present, sir.
27 Rohan Narayan. 227 229
Present, sir.
294
Present, sir. Present, sir. Present, sir.
5318
Present, sir.
20
Present, sir.
53
Present, sir.
479 5479 Ravi Tiwari 5491
Present, sir.
5567 Rishabh Pathak 5575
Present, sir.
5651
Present, sir.
5660
Present, sir.
5678 5678 Sweta Kumari
The 479 present. Written.
Ravi present 5798
Present, sir.
5809
Present, sir.
58111 5811 Premchandra Bharti,
Absent, sir. Absent.
14,
Sir, present.
15,
Present, sir.
17,
Present, sir.
25,
Present, sir.
32, 53,
Present, sir.
95,
Present, sir.
5936,
Present, sir.
5939, Abhijit Jha,
Present, sir. Present, sir.
5957,
Present, sir.
5959,
Present, sir.
5960,
Present, sir.
5992,
Present, sir.
51026,
Yes, sir.
51058,
Present, sir.
541,
Present, sir.
51134,
Present, sir.
51206, Ansika Dwari,
Present, sir.
51235,
Yes, sir.
51246,
Present, sir.
53,
Present, sir.
5123, 51268,
Present, sir.
51315,
Present, sir.
51348,
Present, sir.
51397, 51397, 51399,
Present, sir.
51427, Siprit Padhi,
Present, sir.
51434,
Present, sir.
67,
Present, sir.
51539,
Present, sir.
51603, 51603, Sauradeep Sarkar, 51663,
Present, sir.
51673,
Present, sir.
51883,
Present, sir.
51885,
Present, sir.
51910, Nishita Deo, 51939,
Present, sir.
51985,
Present, sir.
2005,
Present, sir.
2072,
Present,
5207,
sir.
2110,
Present, sir.
2129,
Present, sir.
2187,
Present, sir.
2253,
Present, sir.
2270, Robin Nagar, 2270, 52270, Robin Nagar, 52460,
Present, sir.
52516, Pratyush Rath, 516, 532,
Present, sir.
540,
Present, sir.
680,
Present, sir.
700,
Present, sir.
865,
Attending, sir.
932,
Present, sir.
53469,
Yes, sir.
Okay, thank you to all.